Hello, today we're going to be working on 6.4, analyzing graphs of polynomial functions. So it's the moment we've been waiting for. We're going to be graphing things like x to the fifth and x to the seventh. These graphs are going to end up having something called relative extrema. So those are going to be your extreme highs and lows, but it's not necessarily going to be the overall high and the overall low. These are going to be instead located at your turning points. So that's going to be where you turn from going up to going down, from increasing to decreasing. So on a graph that looks like this, a turning point is going to be this peak here and then this trough here, okay? And one of those is going to be a relative maximum, one of those is going to be a relative minimum. A maximum happens when you go from increasing to decreasing. The minimum happens when you are going from decreasing to increasing, because that's going to create the low points compared to the ones close around them. Now, it's not the overall high and the overall low because this graph goes up forever and down forever. So it's just a relative maximum versus an overall maximum and minimum. So we've been graphing things like x squared in the past. Now, when we graph x squared, we normally would get a parabola. X to the third is going to look somewhat like this, and x to the fourth is going to be a parabola with a couple wiggles in it. So these all have different number of turning points. X squared has one turning point, x to the third has two turning points, and x to the fourth, this graph has three turning points. So the maximum number of turning points is going to be whatever the degree of the polynomial is, minus 1. Now it says maximum because sometimes x to the third, for instance, might look something like this. Oh, that still has two turning points. It might look something like this, where there's actually no turning points at all. So x to the third could have at most two turning points, but it might not have two turning points. It all depends on how the rest of the polynomial plays out. Same thing with your number of zeros. So the max number, I should say, of real zeros, because that's going to be important. The maximum number of real zeros is also going to be based off of the degree. So if we were to look at a graph of x squared, the zeros are going to be your x-intercepts. So looking at each of these, if I were to throw in my x-axis here, the zeros, the real zeros for x squared, well, there would be two of them. X cubed would have three zeros, and x to the fourth would have four real zeros. The maximum number of real zeros is going to equal the degree of the polynomial. So let's go ahead and take that and look at a graph of a polynomial and ask for basically everything we've ever done with graphs before, all in this one problem. So we want to figure out what degree this could be. If it's asking for a description of the degree, we're going to look for even or odd. And because this is ending different directions, one up and one down, this is going to be an odd degree. The leading coefficient is either going to be positive or negative. Since it starts high and ends low, it's kind of mimicking a negative slope, so it is a negative leading coefficient. Your constant is going to be your value where your graph crosses the y-axis. So it's going to be down at -5. The constant is just the number. The y-intercept would be the point. Because in your equation, what's happening is you have y equals negative something x to the third plus a bunch of stuff. The constant at the end would be -5. The number of real zeros are your x-intercepts here, so there would be 3 real zeros. And that lines up because you have 2 turning points. Your x-intercepts are -4, 0, 2, 0, and 7, 0. And that's going to line up with your real zeros. It's just we're going to write them as a solution here. So x equals -4, 2, and 7 would be our solutions. So now what we're going to do is we're going to look at your maximum and your minimum. So your relative minimum is going to be the low value here in the trough. So it's going to be at the point -2, comma, -7. These you're always going to write them as points. So your maximum is going to be over here. It is going to be at the point 4, comma, 3. For f of -4, this is saying when x is negative, or x is +4 rather, what is your y value? So we're going to go when x is 4, my y value is up here at 3. It's just asking you to use this graph in function notation. Domain for this graph is going to be -infinity to +infinity, as is your range because there's arrows going left and right and up and down. So for your increasing and decreasing, this is going to be your x values only. You're looking for where your graph is going up and where your graph is going down. So this first chunk here is going to start decreasing until we get here. Then we're going to be increasing until we get here, and then we're going to be decreasing again. So this x value is at -2, this x value is at 4. On the left is -infinity, and on the right is +infinity. We said we're decreasing, then increasing, then decreasing. So your increasing started when x is -2 and ended when x was 4. Your decreasing started on the left and stopped at -2 for x, but then picked up again when x was 4 and went to the right forever. This is now your new end behavior. That's what your next one is looking at. So as you go to the right, where is your graph going? And since your graph is going down, that's going to be -infinity. The next one is saying, as I go to the left, where's my graph going? And my graph is going up, +infinity. The last two are asking, where's our graph above the x-axis? And where's the graph below your x-axis? And as again, these ones are going to use x values only. And this is dependent on your zeros. So I'm going to erase the notes that I have on my graph so I can more clearly picture that. So where's my graph above? It's going to be above up here and here. Where's my graph below? It's going to be below here and here. So it's above on the left to -4 for my x values, and then again from 2 to 7. And it's below from -4 to 2, and then again from 7 to +infinity. So now what we're going to do is we're going to do this idea, but we're going to be given an equation. So we're going to try to do as much as I can with my equation without using my calculator, and then I'll go to my calculator eventually. My degree for this one is 3 because that's the highest exponent. My leading coefficient is 3 because that's the number out in front. My constant is -4 because that's the number at the end, which means I can graph the point 0, comma, -4. I'm going to have at most 3 real zeros because that's going to match the degree. The maximum number of turning points is the degree minus 1, so I will have at most 2 turning points. We can go ahead and factor this without using our calculators. We are going to use factoring by grouping. So we're going to get 3x plus 1 in both of our groups. And when we get x squared minus 4, we're going to go ahead and factor that further. So my final factored form is x plus 2, x minus 2, and 3x plus 1. Now those are going to give me my zeros, -2, +2, and -1/3, which should match my x-intercept. So -2, 0, 2, 0, and -1/3, 0. My y-intercept I already mentioned here is 0, -4. So now I need to see if I could get a good picture of what the rest of the graph would look like. So since it's x to the third and it's a positive leading coefficient, my graph is going to look something like this. So as I go to the right, my graph should be going up, and as I go to the left, my graph should be going down. So imagine, if you will, my graph will look something like this, and it's going to go something like that. So my domain is going to be negative to positive infinity, as is my range. And then to go above is these two chunks, and below would be these two chunks. So greater than or equal to 0, notice it has the or equal to, so I'm going to use my brackets for this one. So negative 2 to 0 in union with 2 to positive infinity. Less than would be from negative infinity to negative 2, and then again from negative 1/3 to positive 2. Now that I say this, I'm realizing this was not 0. I just misread it. Sorry about that. So it should be negative 1/3 there. Now, to get a real accurate picture of my graph, I would actually go ahead and I would type this in on my graphing calculator, and I would be able to see all of those points that I just got. Notice for this one, I did not ask you for increasing and decreasing, but if I did, you would have to go to the calculator and find out your highs and lows, because you can't just assume based off of this rough sketch that you have the highs and lows. Instead, you should see that the highs and lows are actually different. So we would actually have to calculate that. So let's go ahead and do that for this one. I want you to go ahead and type this in on your calculator, graph it, use your table to get accurate points, and then go ahead and figure out all of these values here. And then I'll come back in a moment after you've had a chance to think about it, and we'll go over all of those answers. Okay, let's go ahead and take a look at this. As you go to the right and the left, you're going up for both of them. There are a maximum of 3 turning points, and this one actually does have 3 turning points. So that kind of lines up. You have a maximum of 4 zeros, and this one also has 4 real zeros. They're just all decimals, so we're going to round to the nearest hundredth. You can see your max and your min there, and your domain and your range. I did want to talk about your increasing intervals and your decreasing intervals together, because they are based off of the x values of your mins and your maxes. And oops, I did forget to write a minimum. It should be negative 0.09 and negative 1.05 as well. So your increasing and your decreasing again are going to be x values only. It's asking where is the graph going down and where is the graph going up. So I can see there's 2 increasing intervals, starting at negative 0.09 and stopping at 0, and then again from 1.84 to the right. Decreasing starts on the left until negative 1.09, and then again from 0 to 1.84. So now we're going to do the greater than and the less than, so I'm going to erase these ones, and the greater than chunks are going to be 3 separate intervals for this one. The less than chunks are going to be down here, and now I'm just realizing how much of a mistake I just made with my range. My range is not negative infinity to positive infinity. That was goofy, because it doesn't point down for forever. So instead my range gets down to a value of negative 0.7.31. So I apologize about that. Please check your range one more time. That was definitely wrong. So looking at greater than 0, I have 3 separate intervals starting on the left. But now for these ones, what I need to do is I need to use my x values for my zeros. So from negative infinity to negative 1.44 would be the first interval. It's just greater than, so I'm using parentheses. From negative 0.57 until positive 0.49 is my next chunk. And then 2.52 to positive infinity would be my third chunk. For less than 0, there's 2 chunks from negative 1.44 all the way to negative 0.57. And then again from 0.49 to 2.52. So thank you very much for listening. Hopefully this helped.